Hi everyone, I'm Jim White, and we're going to talk about water vapor. Next, I'd like to show you an interesting fact about water vapor that you might not be aware of. These are the normal constituents of dry air, and nitrogen is roughly 78% of our atmosphere. Oxygen is 21%. There's almost 1% of argon, and CO2 is 0.04%. Now, nitrogen is a diatomic molecule, which means, or a diatomic gas, I should say, that two atoms of nitrogen stick together. So the molecular weight of nitrogen is 14, so N2 is 28. It's the same way for oxygen. Two oxygen molecules oxygen atoms like to stick together. So the molecular weight of one oxygen atom is 16, but O2 is 32. Argon has a molecular weight of 40, and CO2 comes out at 44. Now, if you multiply each of these molecular weights by the percentage of their constituency, expressed as a decimal, you come up with a molecular weight of dry air of 28.9. Now, water has a molecular weight of 18. That's 16 for the oxygen, and then plus 2 for the hydrogens. So the density of H2O in dry air, or compared to dry air, I should say, is 18 divided by the 28.9, which is 0.622. So water vapor is only 62% as heavy as dry air. Now, if we do the same thing for CO2, we find that CO2 is 1.5 times heavier than air. So this plays an important role in some of the things that water vapor will do. Okay, here's a little chemistry. We burn hydrocarbons to produce energy in a lot of different things. Propane, which we're probably familiar with, has a formula C3H8. So it's 3 carbon atoms and 8 hydrogen atoms. This is hexane, which is C6H14. So there's 6 carbon atoms, and if you add them up, there's 14 hydrogen atoms. Now, when we burn hexane, we're going to get 6 molecules of carbon dioxide, CO2, and 7 molecules of water, H2O. And similar things happen with propane. You just get less CO2 and less water vapor. Now, jet aircraft essentially burn kerosene, and kerosene is a mixture of long-chain hydrocarbons, and each constituency of kerosene varies between a C10 and a C16. And of course, the hydrogens are connected the same way, so the amount of hydrogen will vary. So when a jet aircraft burns kerosene, it produces CO2 and water vapor. And the water vapor is what makes the contrails. Con is for condensation. But when you see the jets in the sky, as you go up in altitude, it's colder. So the hot water vapor coming out of the jet engines condenses into little droplets that we can then see. Now when they burn propane in a hot air balloon, they get carbon dioxide and water vapor. Now we know carbon dioxide is heavier than air and water vapor is lighter than air. So essentially the CO2 would want to work its way out of the bottom of the balloon, the opening at the bottom, and the water vapor would want to rise to the top in the balloon. So I think a significant amount of the lift in a hot air balloon is actually from the water vapor or steam. So next we'll look at the contrails made by kerosene from a jet airplane. Here's a little more chemistry. This is the structural formula of a chemical known as trimethylxanthine. It's a chemical known to modify human behavior. I've personally seen large quantities of this chemical loaded onto passenger aircraft. So what sinister thing is going on here? Are the contrails just water vapor? You be the judge.